A spinal cord injury disrupts the communication between the brain and the body, and today there's no cure for spinal cord injury. Every little thing we can do to actually get this function back would mean already a big chance of improvement for the patient. My name is Lukas Matter. I'm a PhD student at the Department of Microtechnology and Neuroscience, and I mainly research on bioelectronic implants to treat spinal cord injuries. So I did my bachelor's and master's in Germany at the Chalmers University of Technology, and I studied electrical engineering. But when I switched to my master's, I felt the pull that I want to do something which is more towards human impact. And during my master thesis, I met Maria Ashblund, who is my current supervisor here, and she offered me a project to work on the spinal cord. And I was very fascinated by the brain because there are many questions we don't have answers for how our brain works. So I joined her in her group, and this is how I came to Chalmers and came to what I'm doing now. The spinal cord is actually what connects our brain to our body. If you would move along your back with your finger, then what you feel are these different spinal processes. So if you would break this model down, then okay, we'll remove all the bone. What we end up with is some volume like that, where all the different nerve fibers would go through, so back and forth. If something breaks on your spinal cord, then this communication line here will be disrupted, and all the communication towards your brain will be disrupted as well, and that's what we are interested in. How can we help an individual which has this condition to regain some function and to improve their quality of life? So bioelectronics is in general just electronics which interface with the body. It can be things to record body signals, but it can also be devices which stimulate, as for example a pacemaker. You can think of it as a pharmaceutical which you can switch on and off. Today there's no cure for spinal cord injury. So what we did, we developed a bioelectronic implant which could apply an electric field across the spinal cord injury, and we showed that this applied field actually helped to regenerate locomotor function in a rodent model. Imagine like a food wrap, and we can structure conductive paths, so we can structure metals on this food wrap, then actually design an implant which can be used to interface with the spinal cord directly. What we used in the study is some implant like that. So this would be this thin film implant, right? This foil is like 8 micron thick. It's like 1/10 of the thickness of a hair. And then in our smaller size model than a human, I mean, you would need to conform on it, and you have a bit of liquid on it, but it would look something like this, right? This is how the implant would sit on this very small cord. What we always see with people with spinal cord injury, that they are incapable of walking. If you can induce a bit of regeneration, it might not be good enough for a human to independently walk again, but there might be enough newly built connections that they can actually control their bladder or control their bowel. So these would be these small improvements, but they would mean a big improvement in the quality of life of people affected with spinal cord injury. And we believe that this electric field treatment, which we investigated, could be a method to help. But of course, we are aware that we would need to combine this with other therapies. A lot of people were involved in the study, and we do this especially with amazing collaborators in New Zealand at the University of Auckland. What we need to do is scale it up and see how we can make it ready to be tried in humans. So I think if we continue doing that, then we're on a good pathway to help these individuals with a disease where we just don't have a cure yet. And I think as researchers or as people in general, we shouldn't stop there. We shouldn't just accept that there is no cure today. I think we should try to invest our resources to find a cure, and I think we can afford it. Every little thing we can do to actually get this function back would mean already a big chance of improvement for the patient.